Hi, everybody, and welcome to session 11. I'm sorry about the slight delay in the start, but we will just get started right away. We're going to listen to our three presenters first. They each have about 20 minutes, and then we are going to hear from our three discussants, and we will save the last 15 minutes for questions and answers. Feel free to put any questions you have in the chat as we go along, and we will get to them at the end. Also at the end, if time permits, we will let you raise your hands and ask your questions out loud. All right, well, without further ado, we are in session 11, Specialization and Licensing in Occupations. My name is Julia Beckhusen from the U.S. Census Bureau, and our first presenter is Ming Zhu, Occupational Licensing and Labor Market Fluidity. And Ming, you can start talking and just say next whenever you would like me to move forward on the slides.
Okay, great. Thank you so much for this opportunity to be able to present this paper. It's a joint work with Morris Kleiner on occupational licensing and labor market fluidity. So next, firstly, let's start with some motivation. The motivation for this project is we see that occupational licensing has grown rapidly over the past few decades. So in the 1950s, we see that the percentage of workers who are licensed is about 5% for the working population, but now this number has rapidly grown to about 1/5 of the total working population. So in the meantime, we see that as the occupational licensing has grown rapidly, we see that labor market dynamism has declined. Next. So specifically, what we see is that what we are looking at is this occupation to occupation switching rate has gone down in the past few decades. Why do we care about this occupational switching rate? Well, workers, especially younger workers, earlier in their life, they are trying to find their best match using their switching to find whatever the occupation that suits them the most. But if for whatever reason they are not unable to do so, for example, hindered by this occupational licensing requirement, then the result would be that they are not able to or will be having a harder time to switch to their best match occupation and therefore are reduced in welfare. So next, we're going to talk about our research question. Next, please. So what are our research question is the following. What are the effects of occupation licensing on labor market dynamics? So how is that affecting workers switching between occupations or switch in and out of the labor market? And how does licensing affect workers' wage growth? And more importantly, how is this related to welfare? So let's switch to the next slide. Just to give a preview, you can just go several next to show all the results at the same time. Thank you. So our result shows that yes, indeed, that licensing affect workers entry and exit of certain occupations. So to be specific, we see that licensed workers are 5 percentage points less likely to switch occupation, and about 0.6 percentage points less likely to become non-employed. So we do see this kind of, in a sense, job security for workers who are licensed. And compared to the similar counterparts, we see that a condition on switching into an occupation, workers are 8 percentage points less likely to have switched into a licensed occupation if they were working, and 0.5 percentage points less likely if they were non-employed. So we see from this result that perhaps licensing does represent a hurdle or entry obstacle for people who want to switch into these licensed occupations. We see that licensed occupation workers do enjoy a premium, whether they are staying in their occupation or they're switchers, they switch out of their occupation. To be specific, we see that workers who stay in their occupation enjoys about 5.5 percentage points of wage growth across a year. Roughly, it's about 21,000 USD dollars in 2,000 dollars on average. And this number is also there for switchers. For workers who switch out, this number is about 4 percentage points, or roughly about $1,200. And for workers who switch into the occupation who are licensed, this number is about 6.8 percentage points, or roughly speaking, $2,800 on average. So we see that licensed workers are enjoying this premium, whether they stay in their occupation, whether they switch out of their occupation, or if they switch from other occupations to a licensed occupation. And aligned with the literature, we see that for unemployed workers who just find a job and the job is a licensed occupation, they also enjoy this initial wage premium, roughly speaking, about 13.9 percentage points. Then we look at again this initial occupational switching story. We see that licensing can actually account for at least 0.1 percentage point of the decline, or about 7.7% of this total decline in occupational mobility. What this means is that we are providing a link between licensing and the labor market fluidity, and this represents additional channel for welfare effects, right? So, for example, this earlier paper by Kleiner and Sotas, they focus on this general equilibrium static labor market welfare, and this providing this link between licensing and changing occupational switching rate. We're providing another channel of this potential the welfare changes for licensing workers. So next page, please. So our paper is definitely, sitting on ground on a large literature on firstly licensing effects, as well as this labor market dynamism literature. So there's a lot of paper has done great work on effect of licensing on static labor market outcomes. A few papers focus on this dynamic decisions. So we are again trying to build a link between this licensing and the workers' occupational switching, and therefore and so on, wage changes and the welfare changes. So next, please. Let me focus on data, start with the data, and then provide some empirical evidence, and hopefully we'll have some time for the robustness, and we'll talk about results and hopefully some robustness, and I'll conclude. Next, please. So first, let's define licensing. So licensing is a form of regulation that requires individuals who want to perform certain types of work to obtain the permission of the government in order to work for pay. So we are using two data sets for this licensing indicator. One is a CPS, one is SIPP. So our baseline result focusing on CPS. So let me start here. Basically, there are three questions that specifically asking about licensing. The first question is the following: do you have a current active professional certification or state or industry license? And the second question is, were any of your certifications or license issued by federal, state, or local government? If your two answers are yes, then the third question following up is your certification or license required for your job? So the most strict definition that we're following, whatever is in the law, is that we deem workers who answer yes to all three questions as licensed workers. We also in the paper use alternative indicators for example, workers who answer yes to the first question and the second question. So that's a little bit like defined occupation definition, licensing definition. We also use workers who work at a universally licensed occupation as the third definition, just so to check at least qualitatively, our results hold across these definitions. The next page, we're going to show the licensing indicator in SIPP. So in SIPP panel 2014, there are 2 questions customized to licensing. So first one is, has someone earned a professional certificate or license, which is very similar with the CPS question that we see in the previous slide. The second question is the following: is the certification or license issued by federal, state, or local government? So if the answer to both questions are yes, we deem these workers are licensed workers. So there isn't a third follow-up questions on whether this license is required. So we're using the previous dataset as a baseline, but this as a supporting evidence. One thing to mention is that the SIPP 2008 panel in Wave 13 topical module, there are actually also questions about licensing, and there are 3 questions that is very similar to what we see in the previous slides, and with the additional question on whether this licensure is required for your job. So again, we're also using this alternative indicator just to make sure that our results hold across different data sets and across different occupations, occupation licensing definitions. So next, we're going to show the data sources. So we have, we're using, like mentioned, baseline on CPS starting 2016. There are license related questions. We're going to use SIPP panel 2014 for all the years up until 2018. And then we have panel 2008. We're using wave 12, 13, and 14. We use core and topical module for this analysis. We also use SIPP all panels just to use the core data, but link the occupations to those definition on universally licensed occupations, and we check use that definition, how is our result hold. Lastly, we use these 2 data sets to support our analysis. One is this newly built occupational licensing law research project, which is panel on how occupational licensing requirement has evolved over the past few decades across all states in the United States. And for ONET, we can extract the occupational skill measures of each occupation. So next, we're gonna move on to empirical evidence. So next. Firstly, let's take a look at the growth of licensing. Licensing has grown substantially over the past few decades, like many previous paper has mentioned. The share of workers who are licensed has increased. The share of occupations that require licensure has increased. And within occupation licensure is required in more states over time. So here, can you click the graph just as an example? The button, sorry, thanks. So this is from Kleiner and Han, basically showing that over time, we see that for each of these occupations, more and more states requires the occupation to be licensed, right? So each dot is a state, and we show that more and more state over time across this x-axis requires certain occupations to become licensed. So back, please, thank you. Oh, just back. Yeah, thank you. And then now we see that occupational requirements become more costly. So next slide, we're gonna see this requirement change using this new data. We see that the change in requirement covers education. So this data, again, it's a panel data, right? It's occupation across states, across time. And we see changes in requirement covers education costs, licensing costs, renewal time. So, monetary and non-monetary costs are all in this data set. Just to give you a flavor of what we can do in this panel data set, we can see that on the left panel here, we see the occupations, and across occupations, the education requirement starting from roughly 1995 to 2015, we take this 20 years period, we see that the education requirements for all occupations have increased. So take a school counselor as an example. Back in 1995, there isn't much of the requirement. So the note indicates what are these numbers mean. So basically, there isn't much of the education requirement for school counselors back in 1995, but in 2015, the requirement across the country is on average a bachelor's degree. And for architect, for example, back in 1995, the requirement is that you need to have an associated degree on average, but now it's more or less a bachelor degree to a postgraduate graduate degree. So the licensing requirement on the education aspect has increased almost across the board. And for the monetary cost, as you can see in the second and the third columns, you can see, or rather the fourth and the fifth panels, you can see that they also increased. So next, let's move on to the occupation switching rate evidence. So here is just a pure summary statistics. We see that on all four panels, we're calculating the occupational switching rate for switching into an occupation, switching out of the occupation in panel B, in occupation switching from an unemployed worker into an occupation in panel C, and switching out into unemployment in panel D. And the light blue shows the not licensed workers, and the gray shows the licensed workers. So this is just a kind of simple summary statistics, and we see that visually, at least across all different panels, that licensed workers see less switching, whether it's switching in, switching out, switching to unemployment, or switching from unemployment. And next, let's see this bubble graph. Which shows kind of a similar idea. On the x-axis, we plot licensing share, and on the y-axis, I have shown the occupational mobility. So we see this downward trend, and each bubble represents an occupation, and the size of the bubble represents how many people are in that occupation. So basically, we see that for each occupation, the higher the licensing share in that occupation, the lower the occupational mobility when workers switching in. So this represents this basically shows this negative correlation between licensing share, how strong the licensing requirement within this occupation versus the occupational mobility for worker to switch in. So next graph, we're showing the same relationship, but for workers to switch out. So again, the higher the licensing share within this occupation, the less likely worker to switch out. Next, let's work on this our baseline empirical specification. So far we've seen a lot of summary statistics, but to tease out factors such as age, workers' characteristics, these confounding factors, we're running this following analysis. So firstly, we look at workers switching in. So time period is between T-1 and T. So each time T indicates a year change. Okay. So from a year ago to now, YIT-1 indicates whether you have switched occupation or you stayed in the same occupation, and the universe is basically workers who are working in this across this year. And we see that beta-1 is our interest coefficient of interest, that being in a licensed occupation, does that affect the probability of worker who just have switched in? And the controls we including age, gender, race, education, marriage status, income level, union status, as well as the detailed occupation, state, and time fixed effects. So we run similar analysis for workers who switch out. The timing is slightly different. So suppose you are licensed in time T, what's the probability that you switch occupation in time T, switch to a different occupation in time T+1. So next, let's see this baseline results. So let's focus on switching in column first. Sorry, 3 minutes? No. 2 minutes? Oh, 2 minutes. Okay. I think I'm seriously running out of time. So I'll just, without talking about the numbers, basically just the takeaway, believe me, we've done thorough analysis, a lot of robustness checks, but the result holds such that if you're in a licensed occupation, the probability that you switch out to a different occupation, you switch to unemployment, is considerably lower than your unlicensed counterparts. And for people who have just switched occupations, if this new occupation is a licensed occupation, the probability that you have just switched in, whether it's from a different occupation or from unemployment, is much stronger. So let's switch to slide 21. Let's go next, all the way to 21. And we see that, yes, thank you. Licensed occupations, licensed workers enjoy this wage premium, like I mentioned from earlier, that if you're a stayer, the first column, that you enjoy 5.5 percentage point of a wage premium compared to your non-licensed counterparts, whether you switch out, second column, whether you switch in, third column, or whether you're new hires. So we see that licensed occupations do enjoy this premium, and this basically holds whether we include later on we include potential robust analysis, we include instrument, or we include the potential missing variables in our analysis. So I don't think I have much time to cover all these robustness analysis, but since I probably have 1 minute, let me just conclude. So all the way to conclusion, please. Thank you. Oh, sorry, previous slide. Key takeaways. Yeah, next. Oh, I think we're already at the appendix. It's fine. I think it's 28/28. So go, yeah. So just key takeaway, basically we see that licensing decrease the frequency that workers switch occupations, and it can account for about 7.7% of the total decline in occupation switching rate, which offers additional link in occupational licensing and welfare in a dynamic sense, contribute to the static welfare effect literature. And we see that licensing acts as a barrier for workers to entry, especially for those who are already working, because licensing often represent opportunity costs, requires education and additional education and time to train. And licensed occupation workers do enjoy this higher wage premiums, wage growth, whether you're staying in occupation or you switch out of your occupation. And I think I'm done. Thank you for listening.
All right, thank you. We'll move on to the next presenter. Wenchen Wang is going to present her paper, Occupational Licensing in the Public Sector.
So, hello everyone. My name is Wenchen, and today my presentation will be in the paper co-written with my advisor Maurice Kleiner about occupational licensing in the public sector. Can you move on to the next slide, please? So the research question we're looking at in this paper are twofold. The first, we are trying to look at how would occupational licensing affect workers' choice of employment in the public and private sector. And secondly, we focus our analysis on how would licensing in the public sector affect labor market outcomes, including our hourly wages, weekly hours worked, and employment. We also did a welfare analysis for licensing effect in the public sector. So the uniqueness of this analysis is that it's the first one to examine the effects of licensing in the public sector, and we use several robustness methods and different survey data sets to check the validity and implications of our main results. So can you move on to the next one? So just a little bit background, I think Ming covered a lot of it. The reason why we are very interested in licensing is because occupational licensing has an increasing and larger coverage compared with other more traditional labor market institutions compared with minimum wage and unionization. So the number of licensed workers has risen from 5% in the 1950s to 22% by 2018. Conversely, the percentage of unionization has decreased largely in the past few decades, but we still, in our main results, include unionization's effect on labor market outcomes as well, because it's a good comparison to the newly risen labor market institution of licensing. In terms of licensing's effect on the labor market, there generally are two sides of the licensing effect. On the first side, licensing serve as a barriers to entry because of its associated licensing requirements, such as the education requirement, exam requirements, apprenticeship and training program requirements that would prevent workers that cannot reach those requirements outside of the labor market. But on the other hand, occupational licensing can serve as a job market signal for quality that can provide information for the employer, which would otherwise be more costly for them to obtain. So the reason we want to focus on licensing's effect in the public sector is because the labor market for the public and private sector are significantly different from each other. So in the public, there exists significant difference in the labor market in the public and private sector workers. So in the side of the public sector worker, it's a greater role for politicians and bureaucrats, whereas in the private sector, it's more of a market environment, which is largely determined by supply and demand. So because of the difference between the two labor markets, the objective function for these two labor markets are different. The public sector is a social welfare maximization versus in the private sector is more of a performance pay, where the marginal product of workers are the key determinants in this labor market. Can you move on to the next slide, please? And a little bit about the literature. So licensed workers generally in the literature have been found to have a wage premium, and the magnitude of this wage premium ranges from 5 to 15%. And in terms of licensing effect on the workers, on the hours worked and employment, the literature has generally found that licensing generally increases hours worked and reduces labor supply. In terms of the labor market effect of public and private sector, being the public sector in the literature has a rather ambiguous wage effect, but most of the literature has found that public sector workers would have positive compensation effect. And the effects of working in the public sector on employment in the literature are rather inconclusive. Can you move on to the next, please? So we adopt two models in regards to our research question. So for the first research question of analyzing how licensing is affecting the probability of sector choice, we adopt a discrete choice model following a paper written in 2018 by Lang and Palacios. So in this model, we establish different utility functions for different workers in each sectors of public and private. And in the utility functions, we include the expected earnings, individual characteristics such as gender, marital status, age, and licensing. And we incorporate licensing as a measure of proxy for risk aversion parameter in the earnings function. So given the extreme value assumption for distribution of taste tracks, we can derive the probability of an individual choosing a specific sector. But the derivation of this discrete choice dynamic programming model is out of the scope of our paper. We mainly focus on the implementation of this model. So on one hand, the insurance mechanism of public sector has made the job security in this sector higher compared with its private counterpart. Therefore, public sector workers are assumed to be more risk-averse individuals compared with private sector workers. And individuals with higher degrees of risk aversion will have a higher tendency of selecting into the public sector when holding other factors constant. On the other hand, due to the barrier to entry aspects of occupational licensing, it can be hypothesized that people who are more risk averse will select into licensing because workers in licensed occupations enjoy job security and economic rents due to tougher entry requirements that would restrict the supply of labor. So because of these concepts, the implication of this model is that risk-averse individuals proxied by licensing are more inclined to select into the public sector. Okay, move on to the next slide, please. So the second model for our effect and analysis for the effect of licensing on the labor market outcomes, we follow partly from the welfare analysis in Kleiner and Sodas in 2019. So as we discussed before, licensing has two sides of the effect. On the supply side, because of the licensed requirements associated with occupational licensing, it would move the supply curve to the left-hand side, causing a restriction or reduction of the labor supply. And the movement of the supply curve to the left-hand side would result in a welfare loss in this case. And because license would also serve as a job market signal for quality, this would actually shift the demand curve to the right-hand side, and this would result in a welfare benefit. So whether licensing in general has a welfare loss, caused a welfare loss or welfare effect would depend on which side of the supply or demand curve licensing would shift more. And we predict that the effect of licensing in the public sector would be similar to the effect of licensing on the general labor market. Can you move on to the next slide, please? So a little bit about the data before we go into the results. So in our main result, we used data from a current population survey, and the range of this data covers from 2015 to 2021. We used the SIPP data as a robustness check. So in the CPS data, there are 3 questions asked starting from January 2015. So like licensing attainment indicator in our paper, the licensing attainment indicator refers to when an individual answers yes to both of the first 2 questions. That is, when an individual has a current active license and when the license is issued by the federal, state, or local government. And in the SIPP data or in the SIPP sample, we also use the same licensing attainment indicator, that whether they have an active license and whether the license is issued by the governmental agencies. So in our CPS data, the sample includes employee workers aged 16 to 64 and excludes self-employed workers, members of the armed force, and people who are unpaid family workers. And we adopt a data cleaning imputation method actually borrowed from me and Kleiner, Xu and Kleiner, to clean the accurate license indicators in the CPS. So our final sample for the CPS contains over 800,000 observations, of which over 38 or 380,000 are unique individuals, and they cover 442 occupations based on the 2010 census categories. Can you move on to the next? Thanks. So first, let's look at some overall descriptive statistic using the CPS sample. So in the whole sample, there are the majority of the people or the worker in the CPS sample are public sector workers and are private sector workers, and they work in the unlicensed group. The percentage of licensed workers is only 15% in our sample, and the percentage of workers who are in the public sector are only 14%. If we further divide these workers into the public and private sector as well as licensed and unlicensed group, we can see that in the public and private sector, people who are licensed in the public sector are twice as much as those in the private sector. And similarly, in the licensed and unlicensed group comparison, people who work in the licensed group, people who work in the public sector is also twice as large as people who work in the public sector in the unlicensed group. So this is this descriptive refers back to our prediction that licensed worker can serve as a risk aversion parameter and tend to select into the public sector. Can you move on to the next slide, please? So we keep further looking at some descriptive statistics for the labor market outcomes, sample mean. So in the top table, we can see that in the whole sample, the mean hourly wage for the CPS sample worker is around $26.87 using the real wage of 2015. And if we keep dividing them into different license group and public and private sector, we can see that compare licensed group to the unlicensed group, licensed worker comparing the mean has a wage premium of around $7. But this in the public and private sector comparison, their mean hourly wage are pretty similar to each other. And all of the workers in these groups are full-time workers based on the total weekly hours worked. And we also look at the estimated annual population employment, and we divide based on their occupation, and we divide these occupations into two panels. In panel A, we're looking at high state variation in licensing attainment. So we are looking at occupations that have high state variation in terms of whether they need to be licensed. So for example, for dispensing opticians in the US, only 22 states would require an optician to be licensed in order for them to practice. However, in the panel B, we are looking at occupations with low state variation in licensing attainment. So for example, registered nurses needs to be licensed almost everywhere in the US. So if we look at some of the estimated annual population employment, for example, if we take a look at brokerage clerks, it is a fully private occupation, and the estimated annual employment is around 9,000. And looking at teachers, the estimated annual employment is around 14 million. And for teachers, most of them are working in the public sector, but 40% of them work in the private sector. And in terms of teachers' licensing rate, half of the teachers are licensed and half of them are unlicensed. And I also list economists just it's interesting to look at. And the economists are mostly unlicensed, and they mostly work where their distribution of public and private sector are pretty balanced. And the annual population employment for economists using our sample estimation is around 73,000. Can you move on to the next, please? So next we're going to talk about a little bit about our identification strategy. So we basically use a two-way fixed effect regression, but we adopt a control sensitivity and treatment effect bounds method with a detailed description described in Auster 2019. So basically we start with the simple two-way fixed effect regression with Y being the outcome variable, L is the treatment indicator, but we have two sets of controllable covariates. So W1 is the observed covariates and W2 is the unobserved covariates, because we don't get to observe W2 in the real world. So the equation listed here is a theoretical equation. So we also include state by occupation fixed effect as well as year fixed effect in our two-way fixed effect regression. So other than focusing on the coefficients from this regression, we also want to estimate the relative degree of selection on unobservables delta that would result in the true treatment effect being 0. So interpretation for delta would be, if we have large enough delta, then the selection on unobservables would need to be pretty large, or delta times more important than the selection on observables. Then we would safely conclude that our estimation does not suffer from selection on observables. So we can also estimate the bounds of our estimated treatment effects using different values of Rmax. Rmax are the R square from the theoretical regression, where we did observe W2, which is the unobservable covariates, along with the observable covariates of W1 and our treatment covariates, and under the assumption that delta equals 1. Can you move on to the next slide, please? Because we suspect there's a selection of licensed workers into the public into the public and private sector, we also adopt a two-stage correction method from Hackman 1979 to account for the selection bias into the public and private sector. So in the first stage, we run a probability regression with work in the public sector being the dependent variable. And we predict values from the first stage regression to calculate the inverse Mills ratio, which can be considered as the transformation of the predicted individual probabilities of being in the public sector. And then we include this inverse Mills ratio to run the second stage regression of our preferred specification of licensing effect on the labor market outcomes. And we use metro status as an inclusion restriction in the first stage. Can you move on to the next slide, please? So here is our main results or baseline results using the CPS data. So we can see that this is the probability of how licensing would affect sector choice. And we can, from column A to column E, we gradually include individual covariates as well as other controls into our specification. And in column E is the fully controlled and preferred specification we have established. So we can see that in column E, licensed workers are around 4% more likely to select into the public sector. And based on the control sensitivity and parameter analysis, we can see that when we take our max to be around 0.47, the delta equals to 4.51. So this means that our selection on unobservables would need to be 4 times larger than selection on observables for our true treatment to be zero, true treatment effect to be zero. And we think this is a large enough delta for us to conclude that our model does not suffer from selection bias, selection on observables. Can we move on to the next slide? And in our CPS results, we find that licensed workers earn a wage premium of 6.5, and licensed workers tend to work more of around 4.2% compared with unlicensed workers. If you move on to the next slide, and licensed workers or licensing would restrict labor supply by 31.5%. Can you move on to the next slide? And we also list our SIPP results here. So the SIPP results licensing also positively affect workers' choice into the public and private sector. Can you move on to the next? And in our SIPP results, we find that licensing is also have a wage premium. Licensed worker still have a wage premium, but it has a larger wage premium of 11% compared with 6% in the CPS. But in the SIPP results, we do not find any significant results effect of licensing on hours works as well as employment. If you move on to the next slide. So if you go on next. So we also focus our analysis on licensing effect in the public sector, and this would be the graph on the left-hand side. So in the public sector, licensed worker earn a wage premium of around 6.4%. Their total license has a 5% hours worked effect and a negative 25 or 26% employment effect in the public sector. So can you move on to, and we also do other subgroup analysis just to see the results. Can you move on to the next slides? Yeah, next one. So we also did a welfare analysis for licensing in the public sector. So we use a simplified model of welfare analysis in the literature, and we suppose that entire 6.4 wage premium for licensing in the public sector is from market power, and we further assume some other numbers from the Bureau of Labor Statistics. So we can use those numbers to calculate a cost for licensing on the public sector to be $19 billion, and we using our coefficient of licensing effect in the public sector, we can calculate that the welfare effect of licensing in the public sector is around negative 20%. Can you move on to the next slide? So conclusion, licensing is positively associated with probability of being in the public sector, and licensing generally has positive wage effects, positive effects on wage and hours worked, but they have negative effects on employment. This is both in the general, in the whole sample, and also in the public sector. Based on our welfare analysis, licensing approximately results in a 19 billion annual cost in the public sector, and the welfare loss of 20% for the licensed part of the public sector relative to no licensing in the public sector. And our baseline results are generally consistent with our economic models and robust around different subsamples. So that's my presentation. Thanks for listening.
All right, thank you. Moving on to our final presentation. Specialists or Generalists, Cross-Industry Job Mobility and Occupational Wages by Justine Hervé.
Thank you. If you don't mind, I'm going to keep my camera off because it disturbs me a little bit. Okay. So thank you for giving me the opportunity to present this paper. Can you go back to the next slide for a second, please? Okay, yeah. So my name is Justine Hervé. I come from the Stevens Institute of Technology in Hoboken, New Jersey, and the title of this paper is Specialists or Generalists, Cross-Industry Job Mobility and Occupational Wages. Next, please. Yeah. So this project started with the following observation. There is growing evidence that such frictions provide firms with market power in labor markets. Another way to say this is that when workers look for a job, a variety of factors can limit their job options. For example, they could be attached to a specific geographical location, or they could have needs for specific workplace amenities. Or another possibility, and this is closer to what I do in this paper, they could have skills that are so specific that it makes it hard for them to match with the right employer when they look for a job. And so among the sources of such frictions I just mentioned, a recent line of research posits that the specialization of an occupation is an important constraint to the job mobility of workers in that occupation. So this theory has been mostly developed by Naidu, Posner, and Vail in a paper in 2019. And so the hypothesized mechanism is as follows. The more industry-specific an occupation is, the more restricted its labor market, the lower the outside options for workers in that occupation, and therefore, eventually, the lower the wage. However, while this hypothesis has been developed conceptually, the empirical evidence supporting this hypothesis is still scarce. And this is, I think, one of the contributions of this paper. Next, please. Yeah, one more. Yeah, thank you. Now, you might still be wondering about the relevance of this topic. Like, why should you care about the ability of workers to move from one industry or one sector to the next? And workers' ability to switch industry actually plays a few important economic roles. First, it matters for wages, as workers' job mobility impacts workers' outside job options, and therefore indirectly their bargaining power. But second, workers' ability to move from one sector to the next is also important for the reallocation of workers in changing industrial landscapes. So, for instance, if phenomena such as green policies or increased automation or digitization in our societies decimate specific industries, then workers in these industries or these dying industries need to have skills that make them that allow them to be sufficiently flexible or transferable to move to another sector and find a new job. And for workers who are highly industry specific in these dying industries, we could expect that if they don't have a way to retrain or acquire these new skills, they would be particularly penalized in this context. Next, please. And so this brings me to the research question I investigate in this paper. How does the degree of specialization of an occupation affect, first, wages of workers in that occupation, and second, cross-industry mobility for workers in that occupation? Next, please. And so to formalize what I'm going to do in this paper, I'm going to study the effect of what I call industrial specialization on wages. And to be clear, moving forward, in the paper, I define industrial specialization as the degree of specialization of an occupation with respect to the industries employing it. Next. Yeah. So to give you a few examples of that concept of industrial specialization, here I'm giving you two examples of two occupations that are on opposite side of the spectrum of specialization. On the left side, you have an example of an occupation that I would refer to as a specialized occupation, fast food cook, because employment for that occupation is concentrated in mainly one industry, the fast food industry. By contrast, on the right side, you have an example of an occupation that I would refer to as a generalist occupation, data analyst, because employment for that occupation is spread more equally across a wider variety of industries. Next, please. And so in this paper, I'm going to try to investigate the following mechanism. I'm first going to look at the relationship between industry specificity and cross-industry mobility. And next, in a second step, I'm going to look at how cross-industry mobility in turn impact workers' bargaining power under the form of the reservation wage and ultimately their wage level across sectors. Next. Yeah. To do this, I'm going to use two main sources of data. I'm going to use first individual level panel data from the SIPP using the 2014 wave of the SIPP, which provides me with individual level data on wage and job transitions of workers between 2014 and 2017. And to build my my indices of industrial specialization, I'm going to use occupation industry state level panel data from the occupation and employment statistic, which is going to allow me to derive my indices from 2014 all the way to 2017. Next, please. Now, in terms of the contribution of this paper, I think one first contribution is to simply propose an index that's able to empirically capture these concepts, right, of the degree of industrial specialization of an occupation that's been developed by Naidu, Posner, and Vail, for instance. Another contribution is to simply provide empirical and theoretical evidence on the wage implications of industrial specialization. And finally, like a third contribution is to actually identify industry specificity as a possible source of increased mobility costs for workers, and therefore possibly a source of increased fair market power. Next, please. Now, in terms of methodology, the paper proceeds in two steps. In the first part, I'm going to look at the relationship between industry specificity and wages using a set of fixed effects, but most importantly, instrumental variable methods inspired from work by Nevo in 2001, but most recently, Azar, Steinbaum, and Marinescu, and Dreschel. Next. Yeah. Now, in the second step, I'm going to investigate the pathways through which industry specificity might impact wages. And more specifically, I'm going to look at the relationship between first industry specificity and cross-industry mobility. Next. And in the second step, I'm going to look at the relationship between cross-industry mobility in turn possibly impact workers' bargaining power and wages. And for that last step, I'm going to use a model of the labor market that simulates workers' mobility across industries. So it's a model with two important features: multi-sector framework and on-the-job search. And so this is a model that's inspired by the seminal work from Burdett and Mortensen in 1998. Next, please. To give you a brief overview of the findings of the paper, I first find that individuals in more industry-specific occupations have on average lower wages compared to their industry generalist counterparts. Next. On the pathways explaining these initial results, I find that individuals in more industry-specific occupations tend to change industry and occupation less frequently than individuals in less industry-specific occupations. My model simulation results are consistent with these empirical results. I find that a decrease in between sector mobility rates increases wage productivity gaps and decreases wage levels in all sectors where a worker can be employed. So in simple terms, if I allow workers, if workers become less mobile across industries, so more industry specific, we observe an increase in productivity wage gaps, which is a proxy for bargaining power, and a decrease in wages across all sectors. Next. So these results overall support the hypothesis that industry specificity increases barriers to worker mobility across industries and acts as a type of search friction that possibly reinforces firm wage setting power within industries. Next, please. Now, in the next part of the presentation, I'm first going to take you through my empirical investigation of the relationship between industry specificity and wages, and then I'll turn to mechanism, and I'll conclude. So before jumping to the empirical specification, I probably need to explain to you a little better how I capture this idea of industry specificity or industrial specialization. So industry specificity here is measured by the concentration of an occupation's employment across industries. So I construct this CEI index, which stands for concentration of employment across industries. And CEI is going to be defined for each occupation in each state each year, and is simply the sum of the squares of the shares of each industry's employment in an occupation's total employment in a given state. So to be clear, SJOSY is the employment share of industry J, in total employment for occupation O in state S in year Y. Next, please. So to give you a brief overview of the dynamic of the index, CEI is going to range anywhere from 0 for the least concentrated occupation, typically those data analysts I was talking about before, all the way to 10,000 for the most concentrated occupation, the specialized occupation. We could think of fast food worker, logging workers would work also. So before, right below, I'll give you a little drawing to illustrate that idea in a very simplified manner. On the left side, you would have employment like more equally distributed for industry generalist occupation, and then right side, an example of employment distribution for a more industry-specific occupation. Next, please. Now, so I'm going to link this occupation state here, estimates of CEI, to micro-level data from the SIPP. And I am using this data set, I'm going to regress the log of the wage for individual I in occupation O, industry J, and with employer E in state S in month M on the log of the CI, for that worker's occupation in that given state in a given year. Now, to alleviate to a certain extent the concern of omitted variable bias, I'm going to add on the right-hand side of the equation time varying covariate at the occupation, individual, and employer level. And most importantly, I'm going to use a set of fixed effects that will try to account for the most obvious confounders. So first, I'm going to use industry fixed effect, which allow me to account for industry level differences in productivity, which would, of course, simultaneously impact my independent and dependent variable. I'm also going to use state fixed effects to account for state level differences in, let's say, productivity, or state level differences in GDP, or state level differences in minimum wage policies, for instance, which would also impact simultaneously the wage for an occupation, but possibly also the employment structure of an occupation in a given state, and therefore my CEI index. I'm also going to use year-month fixed effect to account for time trends, and I'm adding firm size fixed effect to account for a possible selection effect. So for instance, if more specialized workers tend to select into smaller or bigger industries, and if in turn smaller or bigger industries tend to tend to pay higher or lower wages, then this effect would bias my coefficient on alpha 1 here. So I'm using firm size fixed effect to account for this. Next, please. Yeah, most importantly, I'm going to use occupation group fixed effect at the 2-digit level to account for the task content of occupation. Why am I using 2-digit fixed effect? Because that's the level of precision or detail that Autor and Don use in their paper to capture the task content of occupations. So this allows me to account for the fact, for instance, that highly specialized workers might have more like non-routine or routine task content, or more like cognitive or non-cognitive, and this would also impact their wage. So I try to control for this. Next, please. Finally, in a robustness check, I'm using worker firm fixed effect to purge my estimates for firm or worker level heterogeneity. I only use this worker firm fixed effect in a robustness check, though, because they considerably remove the variation in my data, and therefore decrease the statistical power of my analysis. But I just wanted to mention it here. Next, please. Now, remaining concern in my empirical specification is reverse causality bias, or the possibility that wage in a given state could, of course, drive demand for a given occupation, and therefore impact my CEI index. And so to address the endogeneity of CEI in a given state, I'm going to use instruments that are inspired from work by Nevo, but most recently Azar, Steinbaum, and Marinescu, and Oder and Dreschel. Next, please. And so my first, I'm going to instrument the log of CEI with its average in other states for the same occupation in 2012. So the first instrument is what is commonly referred to as the leave one out instrument. And to be more precise, for example, I'm going to, for instance, instrument the CEI for miners in Wyoming in year Y by the average level of industrial specialization for that same occupation, miners, across all of the states for that same time. And so basically what I'm doing here is I'm cutting I'm breaking the connection between the state level connection between my independent and dependent variable, because it's very unlikely that wage level for miners in Wyoming would be able to impact the average level of CEI for that same occupation across all other states in the United States. Next, please. Now, I'm also to exploit the time varying aspect of my data, the panel aspect of my data. I'm going to build a second instrument. And so I'm also going to instrument the log of CEI with its predicted average in all other states for the same occupation and time period. So the second instrument is CEI, is defined this time at the occupation state year level, and it's going to be the product of two components. First, on the left-hand side, the leave one out average of CEI for a given occupation across all other states, fixing time at 2012. And on the right-hand side, the leave one out average growth rate of CEI for that given occupation between literature. This is, of course, not a Bartik instrument, but it's similar in terms of spirit. You could think of the component on the left-hand side as a share, the share part of the instrument, and then the component on the right side as the shift instrument. So first, like the part on the left side is my exposure to industry specificity, and then the component on the right is the shift, right? How did industry specificity increase like at the national level between 2012 and time t? Next, please. So moving on to the results. Like on the top of this slide, I'm just giving or writing down the specification again so that you're clear on what I'm doing here. And this plot here is just showing you on this plot, I'm just plotting the coefficient on alpha 1 that I obtain with various specifications. So the first coefficient at the top is obtained with the baseline specification. Then the second coefficient, for the second coefficient, I'm adding occupation fixed effect. Third coefficient adds worker firm fixed effect, and the last two coefficients are obtained with IV fixed effects model. So the fourth one is occupation fixed effect IV, and then worker firm fixed effect IV. So what's the main takeaway here? Well, a 1 percentage point increase in CEI is on average associated with a 0.03 percentage point decrease in wages. Next, please. And so what does this mean in terms of, oh, that's the slide before. Yeah, exactly. Thank you. So what does this mean in terms of the magnitude of the effect? That while this effect might seem small when we think of in terms of like percentage point terms, like the economic magnitude is actually sizable. Transforming this result in terms of standard deviation, these estimates suggest that a 1 standard deviation increase in CEI is associated with a 2.5 to 7.9% decrease in real hourly wages. To illustrate this result differently, going from the first CEI quartile to the third CEI quartile in the data decreases wages by 13%. And so taking in consideration that the average wage in CEI Q1 is $20 per hour, a 13% decrease in wage corresponds to on average a $2.6 per hour decrease in hourly wages when we move from CEI Q1 to CEI Q3. So next, please. So in the next part of the paper now, like I'm going to try to understand the mechanisms that could explain this negative relationship between CEI and wages. And the mechanism I'm going to investigate, like my hypothesized mechanism, is that industry specificity negatively impacts wages through a negative effect on cross-industry mobility. So workers who are highly industry specific or less mobile across industries and possibly across occupation, which restricts their employment opportunities and their bargaining power and ultimately their wage. And so first, I'm going to look at the relationship between industry specificity and cross-industry mobility here. Next, please. And a first quick look at that relationship is obtained in this figure. So on this graph, I'm plotting the average industry transition rates across quartiles of industry specificity. I apologize if you hear a child crying on the background. It's just like there's somebody in the house. So the red bar here is basically showing you the average industry transition rate of workers in the most industry generalist occupations. By contrast, the black bar on the right side shows you the average industry transition rate of workers in the most industry specific occupations. So there's a pretty clear pattern emerging here. It looks like industry specific workers tend to change industry less frequently than their industry generalist counterparts. Next, please. Yeah. So in this next slide, I'm exploring something similar, except that I'm replacing the industry transition rate on the y-axis by occupation transition rate. And as you can see, a similar image appears. It looks like industry-specific workers also tend to change occupation less frequently than their industry generalist counterparts. So there's a clear negative correlation between CEI and cross-occupation mobility. Next, please. And so while these two previous graphs are just descriptive results, I try to investigate this result further with regression analysis. And this time I'm going to regress various indices of employment transitions on the log of CEI. And what we observe here is these results confirm what we observed in the two previous graphs. The CEI is negatively correlated with industry, the probability to change industry, but also the probability to change occupation. There doesn't seem to be a specific association between the log of CEI and the likelihood to separate to employment in column 5 and 6. And finally, in column 6, 7, and 8, there might be a possible positive relationship between industry specialization and the probability to become unemployed, but this result weakens in column 8. So the result is clearly not as obvious as what we observe in column 1 and 4, which is a strong negative relationship between CI and industry transitions and occupation transitions. Next, please. Now, building on this negative relationship between industry specificity and cross-industry mobility, I'm gonna try to understand how cross-industry mobility in turn impacts productivity wage gaps and wage level across industries. And to do this, I'm going to use a theoretical model of the labor market. Next, please. So to investigate this last part of the causal path, I'm going to use a model of job mobility across industries. So simply a model that has a multi-sector framework and that where workers are allowed to transfer from one sector to the next. So there's on-the-job search. Workers can receive job offers from the competing sector. And so this is going to be a natural framework for me to interpret the concept of specificity and possibly its consequences in terms of the wage distribution within each sectors. So this little drawing below is just a simple representation of the model because I don't have time to go through the details of the equations. But basically you have two sectors, sector X and sector Y. Workers can be employed in both sectors. They can also be unemployed. And here, the experiment I'm going to run is really going to focus on this transition rate, the between sector transition rate between workers working in sector Y and workers working in sector X. So I'm going to try to understand what happens when workers in sector Y become suddenly more transferable or less industry specific, and when they are allowed to move from sector Y to sector X at a higher rate. Next, please.
I'm just about out of time, so.
Okay.
Wanted to wrap it up.
Yeah, I'll wrap up.
Skip something.
So I'm almost done anyway. Thank you. So basically the experiment I'm going to run here is trying to understand how an increase in cross-sector mobility rate phi for workers in the low productivity sector Y impacts work productivity wage gaps in both sectors, but also wage distributions in both sectors. Next, please. And so to give you, this is a brief overview of the results. On this graph, I'm just plotting the cumulative distribution functions of both in sector X and in sector Y, and the evolution when I allow workers in sector Y to become more transferable, to receive job offers at a higher rate from the competitor sector. And what we observe in simple terms is that when workers in sector Y become more transferable across sectors, there's a shift of the cumulative distribution functions of wages, like in both sectors, a shift to the right with no overlap, which suggests that as transferability increases, as cross-sector mobility increases, the lower and upper bounds of the cumulative distribution functions shift to the right with no overlap. So there's a clear increase in wages in both sectors. And so why is this interesting? Next, please. Well, because while we might expect that, that's like the previous slide, sorry. Yes. While we might expect that that allowing workers in sector Y to become more transferable might be beneficial for them, it's more surprising to see like a positive effect on the wage distributions in sector X. So how might we interpret this result? Well, as workers in industry Y receive more offers from the competitor sector, next, please, they will become more transferable across industries. Next, please. And so because of this, competition between firms in different sectors is going to intensify. Next, please. So here in this model, this is all on-the-job search feature of the model is crucial. Next, like you can just, put all the slide. Next again, This is how on-the-job search feature of the model is crucial because workers can leave their job for a better offer. In this model, firms are going to need to balance worker retention and minimum acceptable wages to strategically optimize profits. And so the increase in labor mobility here is in this model forces firms to increase wage postings, not just in one sector, but in all. So in a way, you could think of the increase in cross-sector mobility FIAs as a mitigating factor for the negative effect of firm market power and wages. So basically, increasing cross-sector mobility increases competition among firms, decreases firm market power within sectors. Next, please. And so to conclude this presentation, to summarize, in this paper, I propose the concept of industrial specialization to capture an occupation's level of industry specificity, and I investigate this as a possible source of friction and downward pressure on wages in low and middle wage labor markets. Next, please. My main findings are as follows. Empirically, I find that in the highly industry-specific workers are less mobile across occupation and industries and have, on average, lower wages. My model simulation results are consistent with this result. I find that a decrease in specificity illustrated in the model by an increase in mobility decreases productivity wage gaps and increases wage levels in all sectors. Next, please. So in terms of policy implications, this means that programs or tools that increase cross-sector mobility might help mitigate labor market frictions and optimize the process of labor reallocation. Next, please. Next again. Thank you. In those types of initiatives already exist in the private sector. You can find now online new online platforms that rely on artificial intelligence that already help workers quantify their skill gaps, and that really help workers understand which skills they would need to acquire if they wanted to move from sector X to sector Y. These platforms also provide links or training for workers to acquire these skills. On the public sector side, there are educational programs that try to foster training on what we call transferable or generalist skills. For instance, the city of New York is currently developing such programs. Next, please. And I'm putting a link here for this like New York Tech Training and Accelerator programs for like an example. And that's it pretty much. Thank you.
All right, thank you. We'll go straight into the discussions. If I can get these slides to work the way I want them to. All right, first we have Mark Klee, who is the discussant for the first two papers.
Okay, thanks, Julia. I'll try to make up some time here so that we can have some time for questions at the end, and then and then I can chime in during the questions if that will help. So I am pleased to be discussing these two papers. They are both really great papers, really a pleasure to read. For the Kleiner and Shu paper, I am really jealous that you guys did this. I have written some on occupational licensing too. And actually what brought me to occupational licensing in grad school was exactly this question. the question of how licensing affects occupational mobility. I never got around to doing it. I'm glad you guys did. You've done it probably better than I would have. Also, I really enjoyed reading the Kleiner and Wong paper. So, I'd never thought before about how licensing might be related to work in the public sector. So, as she kind of walked through how these two kind of like institutions or parts of the labor market interact, I thought, oh yeah, that makes a lot of sense. This is really a great idea. They're two great papers. I encourage you to read them all. And they're really well carried out. And then, of course, there's a standard census disclaimer. So next slide. Okay, so I'm going to start. Since both papers have data cleaning that's basically the same, I'm going to start with some comments that are aimed at both papers. And then at the end, I'll talk about some comments for each paper specifically. I'm actually going to touch base afterwards with both Ming and Wenchen, just because I have a bad habit of having more feedback than I have time to present in. So let's talk about this some more later. So my first point that I think applies to both papers is how you define licensing is using this 3-question series. Do you have a license? Is it administered by a state or local government? And then is it required? So these 3 questions, for the most part, are only asked in the 1st and the 5th month-end sample for CPS. And then they do some imputation in between to try to smooth out some spurious transitions. So as I was going to the BLS website, I noticed that the question about whether the license is required is actually asked in other months too, when respondents change jobs. So I think some of the changes in licensing status that you observe across months, but between month 1 and month 5, might be real transitions in whether your licensing is applicable for your job. And the imputation that you do to try to smooth out these transitions might be smoothing out real changes. So my next comment or question is about how you handle non-response in either the licensing questions or in any of the dependent or independent variables of interest. So for that, that's not really relevant for the 2013, for the 2008 SIPP panel or SIPP that was asked in 2013, since there was no imputation for that. But there is, I think that is an important question for CPS and for the 2014 SIPP. And also, one thing that I think might not have been mentioned was that both papers restrict attention to month-end sample 4 and 8 of CPS because that's when they have good wage data. They don't have good licensing data in those months, but the idea is, with that smoothing algorithm that they perform to licensing, you can adjust licensing to get somewhat more reliable measures of licensing that you can use to evaluate impacts on wages. But as far my reading of the paper was that that sample selection criterion was applied even when the dependent variable of interest is not wages or wage changes. So I wondered if you could kind of preference the month-in sample 1 and 5 results when you're studying other outcomes. Also, another robustness check would be to restrict attention to month-in sample 1 and 5, particularly when those month-in sample correspond to the annual social and economic supplement, since that also has good wage data. And then you would have the most reliable licensing data and good wage data at the same time. Next, please. So my next question is, both papers excluded self-employed workers. And I know, this is pretty standard. a pretty common discuss and critique is, well, why not include the self-employed? But I think it's especially relevant in the context of licensing because here you can think about all of the doctors and lawyers and accountants and others who run their own practice. And in fact, BLS has some off-the-shelf tables describing licensing status by a bunch of observables. One of those observables is class of worker. And you can see that among the self-employed, the licensing share is larger than it is for private sector workers or for federally employed workers. It's only for state and local workers that the fraction of individuals who are licensed is higher, and there that's likely because of the influence of teachers. Again, both papers, the analysis stops with the 2014 panel, but there's 4 more years of data that are available that I'd encourage you to use just to get more sample size, since it seems like for both of these papers, sample size is an issue for SIPP. And you even have an entire panel. So the next point is really interesting. SIPP never never stops surprising you with what you don't know. So for the 2014 SIPP, as I was looking up the data dictionary, I realized that the licensing questions aren't asked of people who don't have a high school degree. So that means that variable e-educ is less than 39. So the upshot here is that for sorts of occupations where it's legal to practice without a high school degree, here you can think of like taxi or truck drivers, barbers, cosmetologists. They don't even get asked whether they're licensed. So my question is, what do you do with those people? Do you treat them as just unlicensed, or do you just drop them from the sample altogether? And here, I think this has important implications for external validity. And I think this is also an important population to study in and of itself, because I know a lot of the reason that NCES has been interested in licensing is that it's a potential path to be skilled through an alternative route. So, if you don't have a high school degree, if you don't have a college degree, maybe you can get this credential that can get you access to better paying jobs or jobs that have better benefits. So, now you might think that some people who are barbers and cosmetologists, for example, they do have to attend barber and cosmetology school, but it's unclear how they might respond to our question about education attainment. Would they answer as from the perspective that barber and cosmetology school are really post-secondary? I don't really know. That's up to interpretation, and I don't think we give good guidance on that. So can you go to the next slide? I'll make my next 2 points really quickly. So for the Kleiner and Shu paper, I'd love to see a discussion of the degree of within occupation variation in the licensing share, and where the identification comes from when you include detailed occupation fixed effects. One thing I've seen in my own work, and I know lots of others are worried about this too, is that there's a lot of variation within occupations where we wouldn't expect there to be any. So is it the case that your identification is coming from mostly measurement error? I think it's probably not the case, because I've seen enough other people try to address this problem that, and the results are always the same, but I still kind of feel uneasy about it. And there are some other ways that you can try to remove the within occupation variation in licensing to kind of address this measurement error concern. For example, the latest versions of the Blair and Chung paper. Julia, can you skip 2 more, and then I'll be done, and hopefully that'll get us closer to closer to, we're, on track. So my main comment for the Kleiner and Wong paper is to try estimating the regression without teachers. The interaction between licensing and the public sector is very different for them than it is for everyone else. I like the idea of, possibly thinking about risk-averse people as being more likely to select into licensing and also more likely to select into the public sector. So if they're selecting along one of those dimensions, do they really need to select along both of them to satisfy their risk preferences? But for teachers, it's entirely different. Being licensed gets you access to a bunch of jobs that pay well and have really good benefits. So I'd be curious to see what the results look like without teachers. Looking at some of the robustness checks and how the results change, I suspect that it wouldn't stand up. But I think it's still important to know, even among among teachers, how licensing and sector choice matters, and whether that's different for public sector or for teachers and non-teachers. Okay, so I'll cut myself off here. Thanks, everyone, and I'll be in touch, Ming and Wenchen.
All right, thank you, Mark, and thank you for going through your comments quickly. Next, we have Clayton Gumber. He is discussing the last paper.
Good morning. So I'll be discussing the paper Specialist or Generalist, Cross-Industry Mobility and Wages by Justine. This is a very interesting paper, very exciting to read. I'll try to be quick as well so that we have time for questions. Next slide, please. So just broad disclaimer, any opinions expressed are my own, not the Census Bureau's. So just as a brief summary of the paper, the question was, how does industry specificity affect mobility across industries and wages? And to borrow the words of the author, it's identifying how industry specificity functions as this kind of impediment to a worker's job search. I see the contributions to this paper as threefold. First, this development of the measure of industry specificity using CEI, then using that measure of CEI to see how it affects workers' wages, whether or not workers who are in these more general occupations versus industry-specific occupations are compensated differently. And then uncovering some of the mechanisms that might modify the relationship between industry specificity and wages. So job mobility and just different kinds of occupational factors. Next slide, please. So I see these strengths of the methodology in this paper in general just coming from a variety of different places. The first is that it's combining 3 different kinds of data sources to explore the effects of industry specificity on wages and mobility. It uses this occupation, employment, and wage statistics from the BLFs to create that independent variable of interest, the CEI measure. It's linked with a full panel of SIPP data, and also brings in some measures from the ONET to get at different kinds of features of occupations. I thought the variables, the control variables, but also just some of the independent variables were really carefully selected. They really help isolate that relationship between the IV and the DV. And like we saw a couple different kinds of types of use in this paper too, individual and demographic characteristics, firm, occupation, and industry features. And just about every time I tried to think of what I would add to the model, I would check the appendices and they were included among the controls. It was very well thought out. Also, there's multiple robustness checks used to validate the findings. In particular, the instrument variable approach really helps guard against reverse causality, but there's also different kinds of estimates used to investigate the extent that seam bias influenced the results, which is very important for the SIPP. Next slide, please. So I think with any kind of research, there's always different kinds of data constraints and just things I would consider to think about. For instance, a lot of this paper investigates, like the effect of these different kinds of monthly transitions, such as moving from one job to another job to unemployment, job to employment. And I was just wondering if something such as periods away without pay, if they were considered among those types of changes for job mobility, and if not, why? And I also want to point out that some of the different kinds of transitions from industry and occupation across the reference year, they may be inconsistent, and this is an issue we discovered in the 2014 SIPP panel. So if you haven't already seen our user note published online, I'd advise you to take a look. I also want to note too that one of these control variables, the one indicating the receipt of the professional certification or license, it can't be linked to a certain or specific job. It can't even be linked to a person's current job. And we only know the issuer of that license. So it's just something to be aware of when using it as a control measure, that it may not specifically relate to their current occupation. And lastly, this one's more of a broader question. I was wondering about the measure used for offshoreability in this paper. It was measured at a more aggregate level of occupations, the group level, as opposed to other measures such as automatability. And I was wondering what the decision was behind that choice. Next slide, please. I did have other questions too as I was reading this paper. And I think the first is, how frequent do workers transition across industries? Since this is kind of the cornerstone of this paper, I think some more descriptive statistics too would help really drive this point home. So why it's important that there may be these wage effects related to a person's job and how specific it is to certain kinds of industries. Which leads me into my next point. What is the practical importance of industry specificity when sometimes we saw these small effects? But I think this was presented very nicely in Justine's presentation in terms of those real wage effects. So that's not so much of an issue, I think, in the long term. I was curious about if allocation has any effect on the results. It's always important since when we think about, especially in terms of a person's job, their occupation and industry, sometimes we allocate those results. And I was wondering if there's any kind of sensitivity analyses to account for that. And lastly, in terms of the conclusion, I was interested in learning more about those resources that could be used to enhance a worker's job search across industries when their skills are unique and not easily transferable. So gaining some of those more generalist features so they can improve their marketability. Next slide, please. So thinking about some future directions for research, I could see this going in a few different ways. And I think the easiest and most straightforward approach would just be replicating the findings in a more recent SIPP panel. So using the 2018 SIPP to see if the findings hold in terms of that negative relationship between CEI and wages. And I thought it'd be interesting too to kind of investigate this issue more in depth by looking at how occupations vary within these industry groups by wages. So thinking maybe about two related occupations that are specific to industries and how they're compensated differently and why. Something like chefs and head cooks versus just cooks. And lastly, I always think the ONET's such a great source of data too. It'd be interesting to look at what other kind of measures could be used to help explain the effects of industry specificity on wages and job mobility. Something like job conditions or if any other kinds of measures are considered. And that'll wrap it up for me. Thank you so much. It was a great paper. Enjoyed reading it.
All right, thank you, Clayton. If anybody has any questions, you can either, or comments, you can put them in the chat window, or you can raise your hand and we can unmute you and you can say your question or comment out loud. Justine, you can go ahead. You wanted to say something?
Yeah, I had a question for the two presenters before me. So do we actually know why we observe this increase in licensing in the past years? Because so that, I understand this is something observed in the data, but do we know why?
Sorry, it's me. Can I just answer like this, or can I just unmute myself?
Yes, go ahead. Go ahead.
All right. So, it's a very big question, a very good question. I think probably the consensus that the increase of this kind of number of licensed occupations and workers are generally motivated to as a consumer protection measure, right? To improve the quality of the service, to better protect the consumer. But there are some obviously unintended effects, and that's what I think Wenchen and my paper are trying to disentangle.
Thank you.
All right, thank you. And there's another question for you, Ming, in the chat. It says, so while labor market fluidity is in general good, it seems to me like in this case, licensed workers do not switch occupations because they are receiving higher wages than they would in non-licensed occupations. So in this case, staying in an occupation is kind of revealed preference that people are happy in their occupation and do not want to switch. Not that they are unable to switch. Do you have any thoughts on how to think about welfare effects in this context?
Yeah, thank you for the question. It's a really good question. I think probably, even though we're like empirically, we're documenting all these kind of reduced switching, whether people are switching out or switching in, but I think a bigger effect is more for people switching in. I agreed with you that for people who are kind of already in the club, in a sense, in the licensing, the occupations, it's a reviewed preference that they are less likely to switch out. And I mean, without further analysis, just kind of accent a guess, I don't think that is a big issue for workers' welfare, but it's more for workers who are trying to switch in, but hindered by increasing occupational licensing requirements, whether it's educational or monetary, and that will be a bigger issue.
Richard, your point is actually related to a question that I had for Ming. So I think it sounds like in your comment or question, the kinds of occupational switches you're thinking about are like switches from one career ladder to another. And the career ladder you're on that has licensing maybe has some higher benefits, either wage benefits or non-pecuniary benefits than others. So why are we worried about an inability to exit? But an important question or a question I had that I hadn't thought of before I read the paper was, do you see heterogeneous effects between kind of like horizontal occupation changes and vertical occupation changes? So for example, like is it possible that the big fixed cost that you put in to obtain the license kind of behaviorally makes you more attached to the licensed occupation and maybe less likely to move up the career ladder where like the entry level rung is licensed. That I mean, it sounds like that kind of occupational exit could be worse for workers.
That's a really good comment, and I think so. Actually, we got some referee reports making the similar kind of point, and I think one way potentially to address this is to, and we're currently working on this, is to look at the occupational tasks, right? So and use that task to measure the degree to like what's the distance between different occupations, and that gives us a way of whether you are moving up the ladder, moving down the ladder, moving very close to like jobs with similar task requirements versus jobs with very largely vastly different occupations, and that can give us a sense of you know, whether people are not able to move because it's just task differentials, or whether it's largely represented by these occupational hurdles, can give us a better sense of the welfare differentials.
Okay, thank you. We just have another maybe 3 minutes left. Does anybody else have a question or comment they'd like to share? Justine again, go ahead.
Yeah, I just had one specific question for my discussant. When you mentioned that in 2014 there were issues with coding, industry coding, would that just be an issue for industry coding or also for occupation?
Hi, Justine. This is Clayton. That was an issue for both industry and occupation. It's a small number of cases. We published a user note on the topic, so I would just say check that out, and it describes the issue a little more in depth.
Okay, great. Thank you. That's very
You're welcome.
useful.
Okay, and there's one more question in the chat. So Wenchen, do you assume that licensing only acts as a signal and has no effect on human capital?
So like I think in the literature, as in like the basic intrinsic setting for occupational licensing. So licensing, for example, let's think about like a cosmetologist. So for them to become licensed, they would need to attain certain educational requirement. So that's normally like a bachelor degree or even associate degree or things like that. And they need to pass an exam. They need to pass training programs or apprenticeship program and things like that. So those information would provide signals for the employers that those licensed workers would pass those kind of tests or kinds of requirements, and they would provide higher quality of services compared with those who cannot or did not pass the license. So like whether licensing has an effect on human capital, I think definitely that's a future direction for like looking at whether like licensing requirements for those licensed workers to obtain those requirements, would those have impact on their, for example, education attainment, on their exam results and things like that. I think that's I'm not sure because I haven't looked at it, but I think that's a future direction to look at if we're interested at how licensing requirement would specifically influence on those human capital requirements. And I think SIPP data has those education, training, those variables. So I think that's a very good direction that research on licensing can go into.
Okay, thank you. Mark, I see your hand's up. Is that from earlier, from just now?
Yeah, I mean, I guess the question is like how far into the break you want to go, because like
Oh, yeah, you're right. It's 12:45. Okay, well, we'll just end here because I know that there's a short break. It's lunchtime, so we should let everybody go and eat before coming back. So what time does the next panel start? I was going to try to say it out loud to be informative, but I don't even know. So is it 1:30 or 1:45 that people should come back to the next one?
1:45 is the listening session.
All right, 1:45. Oh, listening session. That's going to be the best part of this whole conference. Very excited about
yeah,
that.
Please be sure to come back.
that's an important one for us.
Yes. All right. Well, thank you everybody for joining in on this session. Thank you to the presenters and to the discussants who took their time to read the papers and give great comments. And thank you everybody for coming to this inaugural SIPP conference. We really hope to see you this afternoon at the listening session. All right. Thank you, everybody.